Welcome back to Spank Ranch Garage. It's Saturday morning and Facebook Marketplace is striking again. Let's hit the road. So I've been keeping my eye out for a piece of crap old wood chipper. I think I finally found one that is at least in my price range and hopefully isn't totally roached, but we'll see about that. Unfortunately, I have to drive to New Jersey for it. So I'm in some random strip club parking lot and I just bought this turd. And we're about to get on the highway, and I want to see if these bearings even have any grease in them before we go. The tires are not looking so hot. Well, there is a sign of grease in there. So we'll say that side's good to run, or at least good to try. I didn't know that this would be a 6-lug axle because I brought a 5-lug trailer spare. These tires have great tread, but they're pretty rotted. Anyway, quick preview. It's missing the chute thing here. He tells me it's part of this. Somebody ran it over. Fenders are all tore up. It's got a Ford 4-cylinder industrial in it. He said the carburetor's bad and they don't make it anymore, so it's obsolete. We'll see about that. I don't know if I'm buying that story. But otherwise, it seems complete. The motor does crank and sounds good. I didn't really check anything else. We'll make it work. But right now, it's just a matter of getting home in this storm. Got some tow lights on it here because nothing else works. Yeah, I doubt that carb's obsolete, but we'll see. Well, you guys know me. I never buy anything nice, so let's get it home. Can't see this thing in the mirror at all, so I'm keeping an eye on the backup camera just to make sure the wheels aren't smoking and the tires are still on the wheels. All right, we're halfway home. Bearings are staying cool, tires are getting warm, but they ain't as bad as I thought they were. We got a couple spots of some rot, but not as bad as I thought. Haven't lost any parts yet. I think we might make it. Another turd in the driveway, hell yeah. Hooked up a battery. What battery tray? It's got stuff on it. Oily stuff. Looks like we got throttle, choke, oil pressure, temperature. Maybe this was the tach. It's got a hand clutch on it. That's disengaged. That should be engaged. Pretty simple. See if it cranks. No life yet. Alright, doesn't sound horrible. Choke on just for fun. Is that choke on or off? That's off. Pull a little throttle into her. Even got oil pressure. And it's running. The guy told me it doesn't run. No way. Did not expect that. I mean, this thing purrs like a kitten. I'm glad I didn't try to start it at the dude's house, or he would probably not have sold it to me for the price he did. Didn't turn into a milkshake, so the motor's not full of water. This is probably a 1960s or 70s. It's an Asplundh chipper. And these were actually made very close to me. I grew up probably 10 minutes from Chalfont, Pennsylvania. I would assume this thing's, yeah, from the 60s or maybe 70s. I think they called these a whisper chipper, which is ironic because I've heard them run before and they're the loudest thing I ever heard. It's got the little beaver here. And, well, let's get into the rest of it and see if the rest of it turns or is it seized up. Hello? Anybody home? Okay. It's got a pretty small drum on it. It ain't a big chipper, but it is only a 4-cylinder. But if I can run 4-inch branches through this, that'll probably be enough for us, because we can burn, you know, the 6-inch stuff, and then the big stuff I end up keeping. Gonna need more throttle than that. I don't know if it turned or is it locked up. Yeah, one of the reasons I wanted to get one of these is because we have a lot of forest fire issues in West Virginia and the burn bans are frequent. And right now we're burning everything we cut down and clean up, and it's just a pain in the butt to tend to the fire all day. So if I could get a lot of the small stuff taken care of by the chipper, we could use the wood chips anyway, so I think it's worth having one of these. Let's try it again now that we can kind of see what's going on here. So we're not getting much rotation out of the drum. It could just have crap in it that's fallen down the chute over the years. He mentioned to me that this was sitting for 10 years before he took it to a shop to get it running. They said the carburetor was unrepairable, the engine doesn't run. Now we see the engine runs, but the drum won't turn. Could be just a story or another Facebook Marketplace mystery. Clear. Looks like this flips up. Yep. And now we can get to the drum and knives. I don't see anything obviously jamming it from here. It's really as simple as it gets. I mean, it's tool steel knives. Probably there's a block somewhere that shears wood. This is just a big ass heavy steel drum. And then it's got this blower on the side. And I am a fan of the blowers. I wanted to get one with the blower because I think it will carry the brushy stuff better. You know, when you send a treetop through with a bunch of leaves on it. I'm not sure that the older ones without the blower do well with that, but whatever. I'm not picky. This seems to really move nice. Something binds it up every now and again. Getting some movement out of it, just popping the clutch. But I'm not sure what is holding us up here. Could be a locked up bearing. I don't see any wood or anything jammed in here. This looks low, so let's see how bad this is before we get carried away with cranking on her. And it's coming right out the bottom. Okay. We're looking at a potentially damaged rad, or the petcock is leaking, or it was left open. Maybe someone actually winterized this. So I was hoping it was the petcock leaking, but it's not. This whole piece came out of the casting down here. Boy, seems pretty thin. I wonder if I could braze or solder that. We're gonna have to really clean that up and see. I'd prefer not to have to put a rad in this. I'd really like this to be like a zero investment project. Just spray some paint on it and go, but it's never that easy. It's always cheap for a reason. All right. That's the fitting. We gotta re-solder. I think I'm gonna solder it. And you guys might be mad about that, but I'm not very experienced with brazing. I've never brazed brass before, and I'm not confident that I'm able to control my heat well enough to not melt a thin tank like this. The casting, oh, I'd braze this any second of the week, but this tank's really thin. I mean, it does have an edge on it. Maybe it's not as thin, but it's tough to get to too, because you got this whole pinched area back here where it's gonna be hard to get a torch in. Up here is easy. Maybe once it starts flowing, it's flowing. Do you think solder is gonna be good enough? Got these two surfaces cleaned up really nice. So we will see if I can't solder this back together. Yeah, the cast piece isn't hot enough yet. There you go, now she's flowing to her. Boys, we nailed it. Somehow we nailed it. It ain't pretty looking. There's solder everywhere and there's a lot of black crap floating on top. But ultimately I ended up laying it down. It failed its first pressure test. I had a small bubble up here in that hard to reach area. And when I laid it down, I was able to puddle solder between the neck and this rib here. This rib is soldered to the tank or brazed to the tank the whole way. I think this whole thing's actually soldered because I was melting into the factory stuff and I wasn't hot enough to be brazing. But yeah, I got a nice lay through there. It's ugly, but I was able to create a pretty good fillet. So there's a lot of surface area here. I think this is actually gonna work. And two of my concerns are, well, firstly, that huge leak didn't just start. That fitting didn't break off on the way home. So did these guys run this with no coolant in it? Is this motor gonna give me trouble? Who knows? But so far, so good. I don't see anything hitting the ground yet, so we'll dump 2 gallons in it and give it a try. Let's see what we're working with here. All you chipper guys, comment below and tell me I am absolutely stupid and this isn't the right way to do it. Well, it's got a bearing in it with grease. Ooh, yeah, it is. There's water dripping out of the bottom of the grease. It's loosening up. You hear all that noise? Wow. I just can't feel comfortable that these bearings are okay with that much noise. You know, nothing's supposed to be touching. There's gaps between all these blades and all that. That is an insane amount of noise. I think I do need to investigate the bearings for sure. Now, I don't have any experience with these other than playing with a couple at different auctions. I know that engaging the clutch is a long process, even on the 6-cylinder ones. You throttle that thing up and you gotta hold until this catches up, or you'll just stall it. It takes forever to get this up to speed. This is a pretty hefty drum, but look how easy it turns now. So she's broke loose, but the bearings are loud. I'm betting they're pitted or screwed up, so this is gonna turn into a little bit more of a project. Whoa, yeah. That's where the inertia comes from. That is bigger than the flywheel on my dyno. I'll show you just in a second here what I'm looking at, but wow. That is a solid piece of cast, probably almost 3 inches wide. I don't know, 20 inches in diameter. It's a piece of ass right there, baby. But just listen. I mean, to me, those bearings just sound noisy. I'm not super comfortable with them. I don't want to put a lot into this machine, but I feel like bearings and then blade securement is really the only safety issues these could have. So it's probably worth spending whatever it is and get bearings in this. My thoughts were correct that these are inertia-based machines. That's how they get away with a 4-cylinder. You get this thing spooled up, you just throw a piece of tree in there and run. That's why people call them a chuck and duck type chipper. There's nothing controlled or, you know, safe about these things. Now they have hydraulic feeds and things like that, and it's a lot more controlled. All right, so looking at this, you got this big old flywheel here. You got probably a 2.5-inch shaft, maybe 3. And then you see this split here. This indicates to me this is called a QD bushing, and it's a double taper, or maybe a kind of a single taper. But basically, I believe, based on what I see here, that the inside of this flywheel's got a slight taper on it. And then this bushing with its keyway here is opposing this slot. And what happens is you set this where you want it on the shaft, and then when you run these bolts in and pull the flywheel on, it actually squeezes that bushing to this shaft and ties this all together as one piece. It's a really good design, but typically you have jacking bolts where you could run bolts through here and use that to push or pull the flywheel off the QD bushing or take the whole thing off. And I'm not seeing any threads in here. There are indeed 9/16, what are they, 9/16, 14, 9/16, 12 threads way down in there. Don't worry, tapping with an impact isn't the only reckless thing I'm going to do today, so calm your ass down. Cool, so now we can use these bolts to actually push this flywheel off the QD flange. Right now we just try and see what happens. Broke it. Broke the QD bushing. That's not good. That's going to be an expensive one if I can't fix that. Looks cast iron, and the flange just broke on the back. Usually these are steel, and you push against that flange and it pops the taper. It's broken. That is not cool at all. It's broken all 3 bolt holes. Every single one. That is so disappointing. I've never had that happen before. I mean, I guess you could use them as a puller. You could put a puller across here, but that is so lame, guys. Ain't proud of it. Pretty disgusting, but if it works, it works. If not, we're probably gonna have to go to a porta power and some all thread and put a cylinder in here. But I'm gonna get the rosebud out, try to get some heat into this flywheel. It's gonna take forever because it's so massive. And then we'll start rapping on it and hammering on it, and we'll hope for a pop. Well, it is cast iron, so it drills nice. I'm thinking here, maybe I could punch some relief holes in it and get the thing to shrink a little bit, maybe. All right, so now my thought is I drilled a low hole here that leaves the material in the shaft very thin, then I drill a high hole, leaves the material against the flywheel very thin. And then maybe I can wiggle and connect those holes and just make a thousandth of an inch of clearance or something here. You can see that broken flange back there. That's why we're in this situation. I just really am disappointed that they used a cast iron hub on this. Like, I'm not the first person to experience this, nor will I be the last. It seems very common on these machines. Every time someone goes to do the bearings, they end up breaking that hub. There's lots of stories of it online. It just is what it is, I guess. Well, I'm running out of tricks on this one. I think brute force is gonna have to be the way it is. Heat, percussion, stress relief. You know, I got 2 holes bored all the way through this, clean through the back flange. I could see daylight. I made the holes connect. I wiggled them up into the flywheel, into the shaft, so that bushing is not even full 360 anymore. I have it chipping apart at the gap here. I got the keyway to move, and this thing still will not budge. So I guess the next option is order up some 9/16 all thread, a nice thick plate, and put a cylinder in between it, pump it up with a porta power, see if we can get it to pop that way. Day 3 on the flywheel from hell. So here's version 3. 9/16 all thread, grade 5. Couldn't get grade 8 in time. Some really good nuts, washers, 3/4 inch steel plate. I think it's a 40-ton cylinder or something ridiculous. We are into the flywheel, full thread engagement, all set up and square. Time to pump it up and hope for the pop. Got some wood here, so hopefully things fall gently if it is going to come all the way off. Fed my porta power hose through the chute, so that way I'll be working from this perspective, so if something does explode, hopefully it doesn't hit me in the face. Pumping up. Oh my gosh, it's already off. That was a joke. Are you kidding me? All that and it's off? I can't complain, but wow. I mean, that came off buttery smooth. I literally just started to feel some force and it slid right off. Now, I have been soaking this thing in penetrating oil for the last few days. I never believed that that stuff actually helps, but maybe, just maybe it did. That came off very drama-free, no pop, no nothing. It almost makes me wonder if this thing cooled down and broke loose on us or something, because, you know, I was fighting this thing so bad a couple days ago with the torch on it and the custom puller and all that stuff. This is unreal. This is just the tip of the iceberg, too. We're not even to the bearings yet. We are just trying to get the flywheel off, so. I felt something moving so soft. It was like, is the all thread stretching? Something stretching? Nope. That thing just walked right off the front of the bushing. So here's the QD bushing that we absolutely destroyed. This is the hole I drilled. I was able to just scoot through the edge there, just into the good stuff. See where we broke the flange, trying to get her off. So now it's a matter of pulling this off. Sometimes there's a set screw on the key. I don't see a keyway set screw on this one. We could probably just, yeah, she's moving now. So I'll get a 3-jaw puller on this and hopefully make quick work of that. One really challenged me, but you just can't give up. You know, once you're deep enough, you just got to go more force, more force, more force until it comes. Maybe the temperature cycles and the penetrating oil did a nice job. Also heating and cooling with the torch, drilling the holes in it. I did a lot of tricks to hopefully make that thing loosen up. All right, so next move is getting this keyway out. Then we'll be able to pull this cap, hopefully. That'll expose the bearing, probably a snap ring. Then we can pull that and start working on the big cap here, which is going to be a McDoozer. All right, there's no seal or nothing in this. This is just grease and crap. So it's just a retainer. Whoop. All right, so on the good note, so this is our broken QD bushing. On a whim, I ordered this one on eBay, and it's a perfect fit. Fits the shaft, fits the flywheel. This is a QD hub. It is a Series F with a 3-inch bore. That's all you need to know. Series F defines the outer bolt pattern and the taper size. Obviously 3-inch bore. It's got a, I believe it's a 3/4 keyway, 3/8 of an inch deep, so half the size of that. But anyway, I made an offer on this. It's new old stock from a million years ago. $30 delivered. So don't go through Alltech to get this. You can still buy it from them. I heard it's several $100s. This is an off-the-shelf industrial part. 30 bucks. You can always find these cheap from industrial wholesalers that buy out companies and sell everything. That's how I built my dyno as well, and I remember I got these really cheap. Unfortunately, this is another cast iron one. I couldn't find a steel one cheap, but like I said, hopefully I'm never in here again, so that's the next guy's problem if he's got to get that off. Another day, another bearing puller situation. So we got 4 pieces of 1/2-inch rebar pulling from the center of this plate. This plate looks to be cast iron as well. I'm extremely paranoid that I'm going to break this pulling it off. This I don't want to have to make. It's not going to be easily available. So we got to be so careful. I'm going to use the bottle jack this time just because it gives me a little more feel. That 30-ton porta-power, you know, you could be breaking stuff and not even know. We got 2 3/4-inch jack bolts in here. I ran this one down just until I saw the paint crack. So we're doing 2 things here. One, we're trying to move the bearing on this shaft, and then we're also trying to pull this plate out of the main housing. And both are going to be pretty seized. So I'm going to apply heat to the bearing race. I'm going to put a little tension on the bottle jack. I'm going to move the jack bolts, and we're going to shimmy around in that order until hopefully this comes off and nothing's broken. Wish me luck. All right, there we go. Now, I whacked my jack bolts 2 more times. I can almost fit a fingernail between the housing. So I feel that that part's moving. Now we focus on the bearing. Uh-oh. Oh, man. Might need the porta power after all. Oh. Oh. Wow. Wow. Certainly coming out of the housing, but man, we are not getting any shaft action here. Here she comes. All right, watch your eyes. Feels like it's getting easier though. There she is. All right. Pretty cool view of the side of the drum. Shaft is in great shape, no damage there. Got a couple things I need to clean up from my removal process, but that's no problem. You can get a good look at how the blades are held in. They're actually just bolted in with this wedged piece. And this blade is also tapered, so it's a double taper fit. Those are gonna be a doozy to get out too, but we'll get into that another day. They don't look horrible, so I could run it as is, but focus on one thing at a time here. So here's the bearing in the plate. That's a big boy bearing. It's over 6 inches in diameter, 80 millimeter on the inside bore. I think it's 170 on the OD. And it's a 3316 made by New Departure. So we don't need anything departing on this machine at high speed. But anyway, it is a double shielded, which is actually a 77616 is the number, I believe, for that. I found their catalog from the 50s where this bearing is spec'd out. So this is an original old school bearing. There's one of these available on eBay right now for $795. We will not be going that way, but we got to get it out of the housing first. So let's figure that out. Oh yeah, baby. All right, so the outer press fit is nothing like the shaft press, which is good. Because I am getting really scared about cast iron parts. If you guys watched my John Deere video where I broke the power steering gland, getting too aggressive with it, and then this one with the quick disconnect bushing, I need to slow my roll and start being a lot more conservative. You can't just be ram jamming everything, even though I want to. That's why I like working on bigger equipment. You can be rough, but not too rough. Your money for that, for sure. Grease flying out of here. There's no way to grease these. These are maintenance-free bearings. Nobody has greased these, so I think if the RPM is okay, I can get away with rubber seals. In this size, they're rated at 2,700 RPM, so I gotta do some math on the pulleys and see, but I think I'd like to be rubber seal from here out. Yeah, I'm not a bearing expert, but I would tell you that that is beyond add grease and go. That is undesirable. I gotta slide the whole chipper assembly forward to get the belts off. So I'm just trying to make some room for that. Of course, everything is seized and difficult. Just kicking this thing forward with a pry bar so we get our belts off. It'd be tough for you guys to see, but I see C120 here. So it's a C profile belt, 120 on the length. These, like this one here, it's almost broken in half. Luckily, I have a source to get these stupid cheap as well on the surplus. So I didn't want to do belts, but I think we'll throw 4 belts on it since we're in. I ain't looking for perfection here, but seeing rips like that, probably not going to last long, so it is what it is. All right, on this main sheave here, similar situation to the other side, QD bushing, though there's no bolt pattern in here. So this one gets bolted through the through holes in the back. So you'll use the threaded holes that we're holding the flywheel on the other side to actually drive this off. What lessons did we learn last time for breaking this? We got to be careful. No ram ass in here. So we're going to go a 1/16 of a turn at a time, get some percussion into it, maybe get some heat into it. Man, that's moving kind of suspiciously easy. I think it's I think it's coming off. Gotta be. Something's moving. Yeah, this one's coming right off. Dude, I don't know. This is how I've always done QD bushings. I did a bunch on the dyno. I see guys do them at work. I'd never seen an explosion and such a failure like what happened on the flywheel over there. Maybe because that flywheel is just so much mass, it just seizes on there. Doesn't expand at all, I don't know, but boom, that's it. That's the beauty of these QDs. They're usually not a total disaster. But knowing my luck, you know, we just went through 3 days of drama on the other side. I don't know what this thing sounded like on camera. I won't know until I edit it, but the reason pretty much right after I got the engine running, I tore into this is because I could tell there was definite issue in the drum area and it sounded very scary. So these chippers are very scary when they work right, but it's more of like a whizzing noise. You hear the aerodynamic sounds from the blades passing the anvil in the bottom there. This was something I never heard before, and this bearing is indeed bad. So that was just ringing the whole machine. It really did not give me any confidence to continue running it. So not all is a waste. This bearing was locked up. That's what we ended up breaking free to get the drum to turn, but she shot. So maybe. There we go. The wear on these blades doesn't match the remaining condition of the machine. So these have been changed, but the anvil bar has not been flipped. So I don't know how good this thing was cutting for them, but hardware, glad to see that. Comes. So that breaks the wedge loose. That's what that looks like. It's all kind of a friction wedge fit, which is scary, but it's pretty good. And the blade comes right out, the knife, they call it. It's got a couple nicks in it, but I'm not going to sharpen them. Under here then, these are jack bolts that actually you'll extend or retract them to move the blade in and out towards the anvil. So we're not going to make any adjustments right now, but I want to break it all free because once this goes back together, we're going to have to make these adjustments, and I don't want to have to fight every single fastener. Well, I have figured out the chipper code. I did not know this until I cleaned this one that we got up out. On the back side, there's a 3/8, and you can just scoot a ratchet and a 3/8 socket in here and drive it forward like that, and I got that tough one to break loose. So I think with that trick in our toolbox, we'll get this apart. Got one all apart and cleaned up, blew all the holes out. So now we're gonna never seize everything, put it back together. Not going to torque the clamps yet because we're going to have to set the gap once we put this back together. That's the way it should be, ladies and gentlemen. Nice. Why don't you use your 1/4-inch bit socket? Well, I already broke it on this job, so we'll have to wait. Now, hopefully this block we're taking out here has a good side left on it. I can see that 2 of them are used. Usually they have countersinks on the other side, so you can flip them and use it 4 times. If not, we're gonna have to put it in the mill and make a new edge. Nice, baby. That's what I'm talking about. Whew. We got 1 edge left. We'll use it. You see how that edge is rolled over? Not square. This one, pretty worn as well. This one, very worn. And then finally, you got a square edge there. So this thing's on its last life, but it's got 1 more lap in it. Maybe this will show it better now. See just how worn that edge is versus a new edge, which is really sharp. That's just as important as the knives, in my opinion. This anvil's got to be good. Got a couple fags here to replace this disaster. Made in USA, and these are to the exact specification of the original bearings. This is the number if you guys need it. It's a 63162ZC3. I was going to go with a 2RS with a rubber seal. Unfortunately, they're only rated to 2,700 RPMs, and this chipper drum is going to run above that. So while I wanted the rubber sealed bearings, I think we're going to be fine with these. I mean, they lasted 50 years, the originals, so we'll go back with metal shielded. Just try to keep this thing out of the rain when we can, but there's no doubt it's going to get wet. I'm preheating Mrs. Spanky's oven right now to 250 degrees. It's about 120 C. That's what this bearing's rated for. We're going to get this whole part hot, and hopefully the bearing will slide onto this race without too much trouble. This drum's about 50 degrees right now. This will be about 250. Hopefully that gets us a couple thousandths of an inch. $130. So she's gonna need a little more soak time than that. Oh man, she just laughed at me. Oh, and now my whole chipper's tipping. All right guys, we got her on there. There's our snap ring groove. We made it. Had to come up with this stuff in a pinch. I was running through the shop looking for material to build something to get this moving before it froze up totally, and I got it. What I ended up with was this piece of tubing that I bored real quick and then put a countersink in it, and that gets me right over the snap ring groove and sets the bearing. Because originally I was hitting it, and then I realized my tool was hitting that lip there. So I rammed a quick little counter bore in there. Now it fully sets the bearing. This is going to make the other side much less stressful. So having this all lined up and ready to go is going to be great. That was such a job. These bearings are not easy to do. And I don't know if I'd recommend buying a chipper that needs bearings, but the problem is, how do you know when it's gonna need bearings? You could buy one that's quiet and smooth, and then it's shot, you know, pretty quickly. So hopefully reassembly will be smooth. 60 foot-pounds is all it takes to make it happen, apparently. Surplus on eBay, $25 each for some Gates C120s. Well, that's a whole different machine. I can literally talk to you guys. It really is quiet. And this thing's rattling, but you can't hear these bearings at all. It is silent. This thing is going to free coast forever, but it sounds great. I mean, listen to these bearings. What you hear is that aerodynamic noise of the blades. Yes, she chips well. I mean, I threw a little piece of 2x4 in there, and now it's all over the driveway, so we'll have to find some branches to give her a test drive. This is definitely an old Ford deal here. Oh, snap! Guys, I don't know if you can see what's going on in here, but those are rivets on both sides, so this pulley doesn't unbolt from the shaft. Shout out to the fine folks of Turkey for manufacturing this pump. It looks like everything's gonna work. The pulleys are the same, the offset's the same, the flange is different, but the face-to-face is the same, and the bolt pattern lines up. I had to grind some of the casting here to fit under the thermostat boss there, but this should work. It looks to be as direct of a swap as we're gonna get. 1066209. It's from a 1950s Ford farm tractor. I think a Ford 800 or something. I don't know if that's a gas or diesel, don't know anything about those, but it's gonna work. Ain't pretty, but it'll protect the taillight. Quick and dirty cover for the PTO since that was missing as well. This thing looks like a huge piece of junk, being like 7 different colors, so let's give this a 10-minute spray bomb with some Kubota orange.
Brought a filter out, totally forgot to use it. Cool. Looks good to me.
All right, threw 30 bucks of paint on this and 30 minutes of my time. It ain't perfect, but I put close to 0 effort into this. Got paint on the tires. Everyone comment down there saying don't get paint on the tires. I know that gets people on YouTube absolutely distraught. Anyway, taped out the gauges on this. Got all the sheet metal painted. Got my beaver emblem under there. Got to pull the tape off. It's much more presentable now. It's still a piece of crap, but now it's a slightly presentable piece of crap. But above and beyond with the working lights here. I'm gonna gut the whole wire harness and just start over. Really, I only need the lights for one trip, but I try to keep all my crap sellable, so if it turns out I don't like this thing or it doesn't work out good, it's a lot easier to sell when it's street legal. Got tail lights. Put a new one in that side. I got the old one working in this side, and then I got 2 of the antique rear lights working. That third one, not going to waste any time on it. I feel like I already went above and beyond on the legality factor here. Just put a standard 4-wire on it. No need for 7-pin since it doesn't run brakes anyway. This is all nice and wire loomed. Should be good. Runs through the frame like factory. We do need to tow this old girl 400 miles at the end of this week, so I already have this tape. Might as well make it as fancy as possible to show my respect for the DOT and the laws of our nation. Of course, the safety of others as well. Just got this all lined up. You'll probably remember the first time I started it, the belts were really slapping. They were actually hitting the inside of the belt guard, really rattling everything. So pulled the proper tension on them, got them all aligned with a piece of angle iron, no lasers here, and it's good enough. The belts are under control now, everything's happy. Well, she's been out here running for about an hour. Not a single drip of coolant on the ground, which is awesome. That means our rad repair is holding, and so is our new water pump. Coolant looks good. There is a drip of oil though. And the back of the block is pretty wet from where I drained the oil filter, but I don't think that's a new leak. I thought this thing has a toolbox. I haven't even looked in here. Holy crap. What is that? Oh, it's cold. Wow, I can't believe the previous owner left that in here. But for real, I never actually opened this. There's the taillight bracket that I built. Someone broke it off, threw it in there. Here's the clamp I'm missing for the intake. And there's a spare water pump alternator belt. Well guys, this wraps up another absolute turd of a repair here at the Spank Ranch. You know, this chipper was really rough. Honestly, I probably should not have bought this one. I should have waited to find a better one. I paid $1,000 for this thing, and I think I definitely overpaid for it. But luckily, the parts weren't very expensive. I have about $450 in this thing between belts, bearings, paint, lights, a trailer jack, that kind of stuff. So it actually ended up turning out pretty good. This thing works great. I started to use it this summer to get some treetops chipped up and use those wood chips to stabilize some of our areas. So thanks for watching Spank Ranch Garage. As always, let me know what you think down in the comments. Thanks for watching. See you next time.